through some of the most important parts of Chapter 10, which is about capital budgeting. So we're getting into corporate finance, some of the concepts in corporate finance, and really the idea here is understanding how corporations make investment decisions, right? So corporations have the opportunity to take on a number of different projects, and so the goal here is to understand how do they decide which projects to accept and which projects to reject. So there are going to be a couple key concepts here. One of them is called net present value, which is NPV, and another is called the internal rate of return, the IRR. So these two concepts are, pretty fundamental in finance, and in this chapter, I'm hoping to make sure that you guys, have a pretty solid understanding of both of those. So first, let's quickly talk about some of the key terms here. Capital budgeting is, again, it's the process of firms making both short-term and long-term investments, right? It's deciding how to allocate their capital or how to use their capital to generate profits, right? So capital expenditures refer to more long-term investments, which are greater than 1 year, and operating expenditures are related to outlays within 1 year, right? So very short term. So for the most part, we're going to be talking about capital expenditures, which, you should think in your mind that it's relatively longer term, right? At least over a couple years, if not longer. So one way to think about it, and you can run through each of these steps and kind of get a feel for the process, the decision-making process for firms' investment decisions or capital budgeting. But the first thing they do is lay out what are the possibilities of the potential investments that we can make. Perform a review and a financial analysis, kind of figure out what the potential cash flows could be of the project, deciding on really whether or not to make the project or not, and then implementation. So one way to think about it is that firms face a number of projects that they could potentially pursue. Some projects are going to be completely independent, right, or unrelated to each other, and then others are going to be mutually exclusive, meaning that if they choose one project, they're not going to do the other, right? Whereas independent projects would be they choose to do one project, but that doesn't necessarily mean that they don't choose the other, right? So a lot of times, in the examples that we do, we might consider mutually exclusive projects where we have Project A and Project B that we could potentially pursue, but we're only going to pursue one of them, right? And so we have to decide which one is the better option. Another thing to think about is, some firms have, basically an unlimited amount of capital that they could raise to pursue projects, and that's fine. That's, here in the U.S., think about large companies, they oftentimes don't have a problem raising capital. But for smaller firms and for firms outside of the U.S., in particular firms in countries, with more developing financial markets, they have to think about things in terms of capital rationing, right? So they can only raise a certain amount of money, a certain amount of capital that they can use for investments. And so that places a restriction on what they can do, and so they make decisions in light of that restriction. So just another distinguishing feature of capital budgeting. So in the decision process of whether to take on a project or not, there's a couple ways of thinking about how to approach that. One of them is, evaluating based on an accept or reject approach, which is that the firm has a minimum acceptance criterion that that the project either meets or does not meet based on its cash flows, and if it doesn't meet it, then it rejects it. Alternatively, you may have a number of projects that you could potentially pursue, and as the company will decide on what the best ranking measure would be for each project, and then you accept the projects with the highest rankings. So there's what we'll do is let's look at a hypothetical firm, Bennett Company, that has two projects that it could potentially pursue, Project A and Project B, where Project A has an initial investment or cost of $42,000, and Project B has an initial investment of $45,000, right? These are the cash flows of the projects. So, you can see Project A generates $14,000 in years 1 through 5, whereas Project B, the cash flows generated are $28,000 in year 1, $12,000 in year 2, $10,000 in years 3, 4, and 5, right? So one thing that you can immediately see by comparing Project A and Project B is that for Project B, you get paid back, much more quickly. Or in other words, the cash flows up front in the early years are greater than the later years. Whereas Project A, all the cash flows are the same for years 1 through 5. So another way of laying it out, we can look at the timeline. Project A costs $42,000, Project B costs $45,000, and you can see the cash flows that they generate. So, one of the themes that we've kind of talked about consistently since we began the class is that timing matters, right? So you can immediately see here that Project B generates $28,000, $12,000, $10,000, right? So most of the cash flows generated from this project are generated in the first year, right? Whereas Project A, the cash flows generated are equal across years 1 through 5. So because of the timing of the cash flows, you may get a sense that, all else equal, you would probably prefer Project B over Project A simply because you get your investment back much more quickly. One way of viewing this is called the payback method or the payback period, right? The idea here is that it's just computing the amount of time it takes in order to recover your entire initial investment, right? So you're thinking, going back to Project A and Project B, you're thinking, how many years is it going to take for me to recoup my $42,000 that it cost me up front, right? And you can compute that. For Project B, you're thinking, how many years is it going to take me to recoup my original project investment, $45,000, and you can calculate that. So here are the calculations, right? So for Project A, which is simply an annuity, right? Because all the cash flows are the same. You simply divide 42,000 by 14,000, which is the annual cash flow, and you can see that it's 3 years. Project B is a little bit different, but you start with the initial 45,000, and year 1 we generate 28,000. So subtract 28,000 from 45,000. By year 2, you recoup an additional 12,000. So add 12,000 to 28,000. That's a total of 40,000 that's recouped. You have $5,000 left. Year 3, which is 10,000, it only takes half the year to recover the additional 5,000, right? So it took 1 year, 2 years, and then half of the 3rd year. So overall, the payback period for Project B is 2.5 years. So, you can compare just as an initial gauge of which project to pursue is just to look at the payback period. So project A, the payback period is 3 years. Project B, the payback period is 2.5 years, right? So in this sense, project B is preferable, but there are other things we have to think about. This is just kind of an initial assessment. So, you can look through the pros and cons of the payback period. Some of the pros are it's simple, relatively simple to compute. It does take into account timing of cash flows. And probably the best way to think about it is either as an initial assessment or as a supplement to other decision criteria. So in this case, if we go back one slide, for Project A and Project B, there is a difference in the payback period, but it's only 2.5 years and 3 years, right? So it's only a difference of half a year. And that's not that big. However, if we were comparing two projects and we found that the payback period was very, very different, then we might be inclined to, consider the payback period more important. Okay, so there are also some drawbacks to the payback period approach. One is that all we're doing is simply computing the number of years until you get paid back, right? And so you can see what that definitely ignores are the cash flows generated after the payback period, right? So one project may generate a slightly lower payback period, but at the same time, maybe the cash flows end shortly after that, whereas the other project, cash flows continue beyond the payback period. So in terms of the biggest drawback to think about the payback period is that it doesn't include or take into account the cash flows generated after the payback period, and so therefore you can't really think about it as the payback approach as being good at measuring wealth maximization, because that's not what it's doing. All it's doing simply is telling you how many years until you get paid back. So it's getting at the timing of the cash flows, but it's not getting at overall wealth maximization. So here's a personal finance example of a Seema Mehdi who is considering investing $20,000 to obtain a 5% interest in a rental property. She has a 25% tax rate. And so her decision-making process is that as long as she gets paid back in less than 7 years, she'll do it, right? And so her estimates between of how much is generated from the property is between $4,000 and $6,000 per year from her 5% interest. And so you can look at the after-tax cash flows, right? So it ranges from 4 to 6. On an after-tax basis, that would be 3 to 4, 4.5, right? 3,000, 4,500. That would be the range. So we know the initial investment is 20,000, and we know that these annual cash flows are the same, so it kind of mimics an annuity. So that makes the calculation relatively easy. So we do 20,000 divided by 3,000, that's 6.67. 20,000 divided by 4,500 is 4.44. So the 3,000 to 4,500 represents a range, right? We don't know exactly what the cash flow would be, but pessimistically it would be 3,000. Optimistically it would be 4,500. It's somewhere in between there. But from the most pessimistic perspective, she still gets paid back in 6.67 years, which is still less than 7 years, right? And so even in the worst case scenario, this potential investment satisfies her decision condition. So she'll do it. So another example, and you can go through the computations yourself, but let's say you have DeYarman Enterprises considering two mutually exclusive projects named gold and silver. Right? So remember, mutually exclusive means that they will only choose one or the other. So project gold, you can see the initial investment is $50,000 and the cash flows for years 1 through 5 are laid out. Project silver is the same cost of $50,000 and you can see the cash flows laid out like this. Now down here you can see the payback period. That is easily computed because you can see 5,000 plus 5,000 is 10,000 plus 40,000 is 50,000, equaling the investment. So how many years does it take to get paid back? 1, 2, 3, and you're paid back, so 3 years. Project silver, same thing, right? So 40,000, 2,000, giving you 42,000, plus another 8,000 is 50,000. So by year 3, you've totally recouped the initial investment of 50,000. So you can see, maybe one of the limitations of the payback period or how it lacks description, because 3 years, because they both equal 3 years, you can see how the initial cash flows may look very different, right? In Project Gold, most of the cash flow from the payback period is in year 3, whereas Project Silver, most of the cash flow is in year 1. So the payback period approach is simplistic, but maybe sometimes overly simplistic because it doesn't give you some of the details about, some of the timing. So another example, again, payback period. We have Project X and Project Y, both requiring an initial investment of $10,000. Well, the first 2 years, you get paid back completely for Project X. 5 and 5 equals 10. Project Y, 3 plus 4, 7 plus 3 is 10. So it takes 1, 2, 3 years to get paid back. So if your decision were completely based on the payback period, Project X would be preferable to Project Y. Okay, so talked about the payback period approach. Let's go a little bit beyond that and go to one of the major foundational concepts in finance. And this is, very, very important, net present value, or NPV. So basically what the NPV is you can see it here, right? It's the present value of the cash flows generated from the project minus the initial investment. So, so you can see the equation here. And what you see is CF cash flow 0, which is being subtracted out, which is the initial investment that we would make today. CFT refers to the cash flow generated by the project in the future year T, which ranges from 1 to N, so the project lasts N years. R is the discount rate, or the cost of capital, right? So basically what we're doing is, the cash flows that are generated by the project in the future, we're discounting them by, the discount rate. And we're subtracting out the initial investment. So the net present value, the NPV, can either be positive, 0, or negative, right? And our decision is going to be based on that. So if the NPV is greater than 0, we accept the project. If the NPV is less than 0, we reject the project. Why? Go back to the equation, right? So if the project is expected to generate significant cash flows, and after discounting these cash flows, by the discount rate or the cost of capital, if the present value of all of these cash flows collectively exceeds the amount from the initial investment, then we know that it's a good project. If we sum up all of the present value of these cash flows and it's less than the initial investment, then we know that the project is not worth it. Another way of putting it is, like it says here, that if the NPV is greater than 0, then we know we should accept the project. Why? Because that particular project is earning a greater return than its cost of capital. And because of that, the project would increase the market value of the firm. Right? So again, if the NPV is greater than 0, then what that means is that the project is earning a return that is greater than the cost of capital, which is great, right? That's what we want. And as we do that, we increase the market value of the firm. So an example, going back to Bennett Company, right? So we have Project A and Project B. We've already talked about their cash flows. They cost, Project A cost $42,000, Project B cost $45,000, and we have the cash flows laid out like this. Well, remember, the NPV is simply the present value of the cash flows generated by each project, right, minus the initial cost. So we can lay it out on the timeline. So we have Project A, cost $42,000. We have all the cash flows generated. Well, what we do is take each of these cash flows and discount them at the cost of capital to the present value. We subtract out the initial investment, and we get the net present value, or the present value of the project net of its costs. Similarly, for Project B, we have a cost of $45,000 and the cash flows generated by the firm and by the project. We discount them all back to present value. We sum them up. So the total of the cash flows generated is $55,924. We subtract out the initial investment, and we get the net present value. So telling us what this project is worth, right? So you can see Project A and Project B are very similar. One's $11,000, the other is $10,900. Project A is slightly greater. So, based on the NPV alone, if these two projects were mutually exclusive, meaning that we could only choose one, then we would probably go with Project A because the NPV is greater, right? We want projects of greater NPV value, but any project that is less than 0, we would reject, right? So if we summed up all of the present value of these cash flows and it was less than $42,000, then that just means that it's not a wise investment decision. We would be losing money in that case. So something closely related to the NPV, and this is sort of just kind of like a side note, you could construct the equation a little bit differently. Instead of subtracting out the CF0, which is the initial investment, the profitability index divides by CF0, right? That's the only difference in the equations. Otherwise, they're entirely the same. So the decision criteria here, the decision rule is that we accept the project if the profitability index is greater than 1. Right? In other words, if the numerator is larger than the denominator, then we accept the project. So if it's greater than 1, we accept. Going back to figure 10.2, which was this one, right? Project A and Project B, we can compute their profitability indices this way. PIA for Project A would be 53,000 divided by 42,000, 1.26. PIB would be 1.24. Because they are both greater than 0, they're both good projects, right? If they happen to be mutually exclusive, meaning we could only fund one of them, then we would have a slight preference for Project A because it generates a higher profitability index. Another way to think about it, and this is just kind of like an extension of the net present value, is something called economic value added, EVA. So in this case, what we're doing is not necessarily just subtracting out the cost, but we're thinking about what does the project generate in excess of kind of the baseline, which would be the cost of capital. The best way to see it or think of it is in terms of an example. So let's say a project costs $1 million up front and it generates $120,000 in perpetuity. And the firm's cost of capital is 10%. So what we do is the present value of this annuity cash flow stream is going to be $120,000 divided by 0.1. Hopefully you recognize that equation by now. That's just the present value of an annuity, right? Cash flow divided by the discount rate. Okay, so we have the present value of the project and the cost right here, and that's part of the NPV, right? Which is what we just did, except in reverse order. It was this minus this equals 200,000. So net present value is 200,000, which is great. It's greater than 0. We accept the project. What economic value added says that what does this project generate in excess of an investment that generates the cost of capital? That type of investment would be $1 million times 10%, generating 100,000 each year, right? So 120,000 is one of the cash flows minus 100,000, which would be the cash flow at 10%. That gives us, the difference is 20,000. That gives us the economic value added. So again, it's kind of similar to the NPV, because the NPV is telling us whether the net present value is greater than 0 or less than 0. Economic value added tells us how much the project adds to the wealth of the firm by generating a return that is in excess of 10%. Okay. Another way of approaching it is still staying within the discounted cash flows world. What we're going to do is, instead of discounting the cash flows at the discount rate and seeing whether the NPV is greater than 0 or not, what we're going to do is discount the cash flows at the internal rate of return of the project. So it's called internal rate of return, but it's the implied rate of return on a project given a set of cash flows. So a project may have a certain set of cash flows, and we're asking ourselves, what kind of return is generated on that project? And the idea is that, if we have a project that is generating 20% and our cost of capital is only 10%, then it makes sense to invest. On the other hand, if the internal rate of return of a project is only 5% and our cost of capital is 10%, then it wouldn't make sense to take on the project, right? Because we'd be losing money or decreasing the value of the firm. So it's just another way of approaching it, but the internal rate of return, the IRR, is another major foundational principle in finance. Maybe not as big as the NPV, net present value, but it's still, in terms of this chapter, it's definitely a second, right? So, again, the internal rate of return is, given a project with a set of cash flows, what is the rate of return implied by that project? So it's a little bit less direct as the NPV, I think, but it's still intuitive. It still kind of makes sense. And again, this chapter is about capital budgeting, so it's about whether or not to accept a project. And the reason we're computing the implied rate of return on a project is to see whether it's greater than the cost of capital. Because the cost of capital represents how much we're going to pay to fund the project. And if it costs more than what the project generates, it doesn't make sense to do it. So, if the IRR, if the internal rate of return, is greater than the cost of capital, we accept. If it's less, we reject. So here's, this might help to clarify things or solidify it in your mind. So going back to Project A and Project B, Project A again has a cost of $42,000 and generates $14,000 in years 1 through 5. Now for the NPV, what we would have done is discount these at the cost of capital, but that's not what we're doing for the IRR. What we're doing is saying, given the cost of $42,000, given these cash flows, what rate of return is implied from these cash flows? This is something we have to do in the financial calculator, right? In fact, it's the same thing as you would be, computing the yield to maturity, right? Because you're inputting everything in the calculator except for I, and so you would be computing I. So the IRR, which is what we don't know, which is why there's a question mark next to it, right? So we can compute the IRR for Project A and Project B, and interestingly, what we find is that for Project A, internal rate of return is 19.9%, whereas for Project B, it's 21.7%. Now, remember from the NPV calculations, we had a slight preference for Project A. But now, for the internal rate of return, we have a slight preference for Project B. That should tell you that, in the calculations of NPV versus IRR, there are slight differences that can lead to, different decision making. So if it were based on IRR, we would choose Project B over Project A. If we're based on NPV, we would choose Project A over Project B. So so there's a conflict between IRR and NPV in this case. But but the conflict is limited to choosing projects that we would accept, right? We would accept both projects just because, the benefits exceed the cost, right? In other words, the NPV, when the NPV is greater than 0, the IRR will be greater than the cost of capital. But comparing two projects that we both like, right? We like both Project A and Project B, but deciding between the two, you may have slight differences in the decision making between the NPV process and the IRR. So it's a little bit confusing, but one of the bottom lines is that both methods always acceptability or non-acceptability of projects. There is not going to be a case where you would accept it under the IRR and you would not under the NPV, right? In both methods, they have to reach the same conclusion or decision about accepting or rejecting the project. One of the reasons for this is that there are implicit assumptions in the calculations about reinvestment of the cash flows. So after the cash flow is received, there's an assumption about what rate it's reinvested at. And so the NPV assumes that cash flows are reinvested at the cost of capital, whereas the IRR assumes that they're reinvested at the IRR, which oftentimes is going to be greater than the cost of capital. This is where the difference lies in the calculation, this is what causes the slight difference in decision making between the NPV and the IRR, is the reinvestment rate of the NPV, assuming it's the cost of capital, or the IRR, assuming it's the IRR itself, right? So go back to the cash flows, right? So for project A, it's a 5-year project, right? But we receive $14,000 in year 1, and there's an assumption about what rate it's reinvested at. But that's where the difference lies. And so this is all to say that, between two projects that we like, there may be slightly different decisions made about whether to accept one project over the other for the IRR method and the NPV method. Here's another way of graphically depicting the NPV profile. And you can see the implied IRR for project A and project B here. Now on the x-axis we have the discount rate, right? And on the y-axis we have the net present value. And you can see for project A, that is in red, you can see that at the point that it hits an NPV of 0 is when the IRR is at the IRR of 19.9%. Okay, so if you were to increase the discount rate in the NPV calculation at 19.9%, you would find that the NPV is 0. Now for project B, in the blue line, you can see that if you were to increase the discount rate, it would lower the NPV, and at the point of the IRR, which is 21.7%, that is the same point at which the NPV would be equal to 0. And we'll stop right there.